One end of a 10 centimeter long silk thread is fixed to a large vertical surface of a charged non-conducting plate, and the other end is fastened to a small ball having a mass of 10 gram and a charge of 4 into 10 to the power minus 6 coulomb. In equilibrium, the thread makes an angle of 60 degree with the vertical. Find the surface charge density on the plate. Now this question can be better understood by drawing a sketch. So first of all, let's draw the sketch. I do have a large vertical non-conducting plate and it is having a charge on it, let's say Q charge. Alright, and a silk thread is fastened to it, a ball of mass 10 grams is attached to it. Fine, so there will be an mg force downward. Since the ball is also charged and the non-conducting plate is also charged, there will be an electric field in this very direction. So the force will act on the ball in this direction, that will be equal to QE, and at equilibrium the thread makes an angle of 60 degree with the vertical. This angle is 60 degree and this angle is also 60 degree. Let's say there is a tension T in the thread, so the component of tension comes out to be T cos 60 and this one will be T sin 60. So I can write at equilibrium T cos 60 is equals to mg and T sin of 60 is given by QE. Taking ratio of 2 and 1, I can write tan of 60 is equals to QE by mg. Fine. Now moving further, we know that electric field due to a long charged non-conducting plate is given by sigma by 2 epsilon naught, where sigma is the surface charge density of the non-conducting plate. So I substitute this electric field over here, so I can write tan of 60 is equal to Q by mg into sigma by 2 epsilon naught. Now I do have to calculate the sigma, that is the surface charge density of the plate, and I do know all the remaining variables. That is, I know the value of Q and M and then G and epsilon naught, that's but obvious. So tan 60 is root 3. The charge Q is given as 4 into 10 to the power minus 6. Mass of the ball is 10 grams, that is 0.010 kg into 9.8 into 2 into 8.85, 10 to the power minus 12, and sigma is as it is. So just solve this equation for the value of sigma. I get the value of sigma as 7.5 into 10 to the power minus 7 coulomb per meter square. That is our answer.